Welcome to this presentation on Machanism AI Assembly and its implementation, the Machai Project. In this session, we'll delve into how Machanism harnesses artificial intelligence to streamline and automate application assembly through modular libraries and intelligent semantic search functionality. More detailed information on how the system works can be found on the AI Assembly page at machanism.org. Machai harnesses the power of GenAI to transform how customer projects are assembled using libraries from the Machanism platform. At the core of this approach is the Bindex.json file, a structured metadata descriptor designed specifically to enable automated assembly and configuration. The term Bindex comes from brick index, which is based on the Lego analogy. Like Lego bricks, libraries are seen as modular components that can be easily assembled to build customized applications. The Machanism AI Assembly is designed to streamline the process of application assembly using modular libraries. At the core of this process is the Bindex.json, a descriptor file prepared by library developers during the creation of their libraries. While this step is essential, it is not required from the user's perspective. For users, the process begins with providing application requirements in a natural language query. GenAI analyzes the intent behind this query and generates embeddings to perform a semantic search within the vector database. The database, which hosts the pre-created Bindex.json files, identifies and ranks the most relevant libraries and artifacts that match the user's needs. Leveraging its structured metadata, the Bindex.json file enables GenAI to return libraries that are directly aligned with the requirements. These recommendations include details about the libraries, their features, integration points, and specific usage examples. This approach ensures that developers have access to all the necessary resources to assemble their applications faster and more efficiently. The description property in the Bindex.json file plays a vital role in enabling semantic search for application assembly. It serves as the foundation for generating embeddings, providing all necessary contextual and project-specific information. This description is automatically crafted from the project's details and additional content, ensuring accurate and meaningful representation for intelligent library selection. Next, we will look at the Machai Project, which serves as the implementation of the approach we've just discussed. Machai applies the described methodology, integrating Bindex.json metadata and semantic search to enable efficient and automated assembly of applications using Machanism libraries. You can download the latest version of the Machai CLI as a .jar file from the link provided below. This tool will allow you to utilize the features of the Machai project for automated application assembly. Download the .jar file to your local machine and place it in a dedicated folder. You can choose a specific directory if you plan to create and register libraries or use a directory designated for your new project. I will download the Machai.jar file and place it in the folder created specifically for testing the assembly process. Next, we need to set up the required environment variables. The following variables must be configured. Bindex reg password, the password for write access to the registration database. Not required for assembly commands. OpenAI API key, this is the API key for accessing OpenAI services. Ensure these variables are defined correctly before proceeding with the assembly process. To run the Machai CLI, open a terminal or command prompt and navigate to the directory where the Machai.jar file is located. Execute the following command. Once the command is executed, the Machai CLI will launch, displaying its banner and a prompt where you can begin entering commands. To explore the available functionality, you can use the help command to view a list of options and commands provided by the tool. To generate a Bindex.json file for your library, use the Bindex command in the Machai CLI. Navigate to your library's root directory and execute the Bindex command. Alternatively, if you are running the Machai CLI from a different location, you can specify the actual path to your library directory as part of the command. The CLI will analyze project files, including pom.xml, source code, and other metadata, and automatically create a structured Bindex.json file tailored for your library. Generating a Bindex.json file for your library uses GenAI capabilities to analyze the library's content. As a result, this operation may take some time to complete. Please allow the process to run and ensure you have the necessary resources available for the analysis. After the Bindex.json file has been generated, the next step is to validate and edit its contents. It is recommended to inspect the file, located at Bindex folder, to verify its accuracy. You can manually edit the file to refine descriptions, update metadata, or adjust integration details to ensure it fully aligns with the library's features and intended usage. As part of the validation process, pay close attention to the description property in the Bindex.json file. This field is critical for generating embeddings and enabling effective semantic search during application assembly. Review the description to ensure it provides all relevant contextual and project-specific information, and update it as necessary to improve clarity and accuracy. Once you are satisfied with the metadata in the Bindex.json file, the final step is to register your library on the Machanism platform. Using the Machai CLI, you can execute the register command. This command uploads the library's metadata to the platform, making it discoverable and ready for users to leverage in their application assembly processes. To verify that the registration process was successful and ensure your library has been uploaded to the platform, use the find command. As you can see, the Bindex.json file has been successfully registered. Your library is now available on the platform and ready to be discovered and utilized in application assembly processes. Since I have already created all the Bindex files for the core projects, I will proceed to register all these modules using the Machai CLI. This ensures that all core libraries are available on the Machanism platform for seamless integration into application assembly processes. This process uploads the library metadata to the Machanism platform, making it available for application assembly. Please note that the operation may take some time to complete, so we ask for your patience as the libraries are successfully registered. To confirm the success of the registration process, we will use the find command to check the availability of the registered libraries. This step ensures that the uploaded Bindex.json metadata is correctly stored and accessible on the Machanism platform. And finally, let's assemble our project. To start, we will use the assembly command, followed by a natural language query to define the application requirements. Now let's check the output project folder. It's currently empty. We will now execute the assembly command to demonstrate the Machai CLI's ability to automate application assembly. The command we will use is as follows. Assembly, create a Spring application for user login by Commerce Tool. This command instructs the Machai system to generate an application based on a provided high-level requirement. Leveraging GenAI and the semantic search capabilities of the platform, it will identify the relevant libraries and create an application tailored to the specified functionality. The project assembly process has completed successfully. Let's examine the dependencies selected by the AI assembly process. This will allow us to review the libraries and modules utilized in the generated project and ensure they align with the requirements provided. As you can see, the AI assembly process utilized Machai libraries version 0.0.3 in the project dependencies. Additionally, the overall structure of the pom.xml file looks correct and well configured for the assembled project. Now, let's proceed to build the assembled project. This step will validate the generated configuration and ensure that all dependencies are correctly implemented for a successful build. We will now run the maven install command to build the project. This will compile the source code and package the application. Oops, the build failed. No problem, let's take a closer look at the compilation errors to identify the issues and determine what changes are needed to fix them. It appears there's an issue with a package configuration. Let's go ahead and fix this. The next issue appears to be more complex, as it involves using the correct constructors in the code. Let's carefully review the affected areas and update the implementation to ensure compatibility with the expected configuration. Let's try running the maven install command again after making the necessary corrections. This will verify whether the resolved issues have addressed all build errors and confirm that the project can be successfully compiled and packaged. The project has been successfully built without any errors. And here's another useful command, prompt. For example, if the assembly command didn't generate a readme.md file, you can easily create it by using the prompt command. Simply run the following: prompt create readme.md. This allows you to quickly generate additional project assets or scripts as needed, making the assembly process even more flexible and efficient. This concludes our brief overview of AI-powered library assembly for the Machanism platform. In the next set of videos, we'll continue to explore the capabilities of AI in building applications across different technology stacks. Thank you for watching.